So children, today we will discuss numericals in sound. How to do basic numericals. Okay, please check the link in description. Okay, that's sums I will discuss. First 10 sums I will discuss. Remaining 10 sums you do as homework. Okay, before doing this numerical, basic terms again I will just give a small explanation and their formulas. All of you try to follow it. First I told you about frequency. Frequency is number of waves occurring in 1 second. 1 second. Time period and its units are hertz. Its units are hertz. Time period. Time period is and formula is for frequency 1 by time period. And time period means time taken. What is time period, children? Time taken to complete one full wave, children. Okay. Time taken to complete one full wave. One wave. Okay, time period is 1 by frequency and units are seconds with each other. Means time taken for one wave is called time period, or one oscillation, or one cycle, or one vibration. Anything is same nature, or one rotation. Time taken for one wave is called one time period. And velocity formula is, and wavelength I have to say, no children, wavelength. What is wavelength? The distance between two crests or two tops. Anything is okay. Anything is wavelength. Or like this also. This is also wavelength. From here to here also it is called wavelength. Because children see here, from here to here I am saying wavelength. No? If I bring this point here, this point also come here. This is only wave. No? Wavelength means length of the wave. Wavelength means length of the wave. Anything is okay, children. Wavelength. Okay. You should have understanding, clear understanding. Then only you can do the sums. Next, velocity formula is, and the wavelength is due to lambda. Velocity formula V is equal to n lambda. N means frequency. Or we can write F lambda. Your wish. No problem. Or V is equal to, instead of F I can write 1 by T also. 1 by T lambda. Anything you can write, because frequency is 1 by 10. And amplitude also I was discussing. What is amplitude? Maximum displacement of vibrating particle from mean position. This is mean position. How much maximum distance it is going? That is called amplitude. These are the four important terms. So basing on these terms, we'll do some numericals. Please check, children. First 10 numericals I will do. Remaining 10 numericals you do as homework. Okay. First 10 numericals I am doing. From basic level to little bit complex variety I will go. All of you see first sum. All of you see, children, first sum. Okay. So what is the velocity? What is the velocity? If frequency is 10 hertz and wavelength is 2 meters, basic level variety, V is equal to F lambda. So V is equal to 10 into 2. So V is equal to 20 meters per second is velocity of what? Wave. Velocity of wave. Basic level assumption. Frequency is given, wavelength is given. Frequency into wavelength is velocity. That's all. Okay, children? You may get, sir, how you got this formula, you may get doubt, I will show you. Children, velocity means distance by time. All of you know. Velocity means distance by time. Okay. Distance here means lambda no. Distance here means lambda no. And 1 by time period is what, children? 1 by time period is what? Frequency. Like that I got formula. Again I am saying velocity is equal to distance by time or displacement by time, whatever it is. Okay. So displacement I wrote it as wavelength by time. 1 by time is what, children? Frequency. So frequency. Like this I got this form. Okay. Next sum. Next sum I'm saying you have to see second sum. Second sum. Please see here, children. What is the velocity whose time period is 2 seconds? What is the velocity? What is the velocity whose time period is 2 seconds and wavelength is 3 meters? Children, V is equal to F lambda. V. Or instead of F we can write 1 by T also. So this is 3, this is 2. So V is equal to 1.5 meters per second is the velocity of the wave. Frequencies I wrote on by time. Like that we can do. Third sum. Please see, children, you have to concentrate. What is the velocity whose distance between crest and top is 2 meters and frequency is 5 hertz? Frequency is 5 hertz. Okay. And children, like this it is there. This is crest, this is crest, this is top. Between crest and crest is 1 wavelength. All of you know. Okay. So from here to here, wavelength. But I gave there in the sum, you please see, between crest and trough is 2 meters. From here to here means here. The distance between here to here is lambda by 2. So children, all of you see here, the distance between, please see here children, what they give. The distance between crest and trough is 2 meters. From here to here 2 means, from here to here also 2 no children. Or lambda by 2 is 2. So lambda is 4. Those who didn't understand, again I am saying, from here to here 2 means, from here to here also 2 no children, because exactly crest and trough will be half. So 2 plus 2 is 4. Or half is lambda by 2. Lambda by 2 is 2 I gave. So lambda is equal to 4. Please, Nana, all of you mute your audios. Mute your audios. V is equal to F lambda. V is equal to 5 into 4. V is equal to 20 meters per second. Fourth question. What is the velocity of wave whose distance between 10 crests is 20 meters and frequency is 10 hertz? Frequency is 10 hertz, children. Z they give 10 hertz. And distance, wavelength, directly they did not give, children. They gave distance between 10 crests, children. One distance between two crests. Okay, children. Distance between two crests is one wavelength. Okay, distance between two crests is one wavelength. Okay, now you're able to. Distance between two crests is one wavelength. He said distance between 10 crests is, distance between 10 crests is 20 meters. Distance between 10 crests is 20 meters. What is distance between two crests? How much? Direct proportion. Children, try to understand. Distance between two crests is wavelength. We want that only, no wavelength. We want wavelength. Distance between two. He gave distance between 10 crests is 20. Between 10 crests means like this, children, like this, like this, like this, like this, like this. Distance between 10 crests is 20. Distance between two crests is how much? That's all. So how we will do, children? Direct proportion. Direct proportion means 2 by 10 is equal to lambda by 20. 2 by 10 is equal to lambda by 20. Okay, so bring 20 up, children. 2 into 20 by 10 is equal to lambda. Hope you are able to understand. 10 twos. So lambda is equal to 4 meters. 4 meters. Distance between two crests is 4 meters. Okay, children? You should not get panic. You should not get confusion, children. Distance between two crests is 4 meters. Now, so velocity is equal to frequency into lambda. So 10 into 4 is 40 meters per second is the answer. Okay, children? One more. I hope all of you are able to follow. Please, children, see here. Next question. Find the time period if the velocity is 100. They gave velocity is 100 meters per second. Velocity is 100 meters per second. They gave, children, see here. And wavelength is 20. Wavelength is 20 meters. Find time period is asking. So first find frequency. Once you get frequency, you can find time period. Or directly you can find out, children, your wish. Time period is asking your wish. V is equal to F lambda. V is equal to 1 by T lambda. V is how much, children? 100. 1 by T into lambda is 20. Okay, children? So T you bring up, 100 will go down. So T is equal to 20 by 100. 20 by 100 means 0.2 seconds. 0.2 seconds. You have to copy, children. Next one. What is the frequency and time period if 100 waves occur in 20 seconds, children? Okay, 100 waves are occurring in 20 seconds. I will rub all these things and I will explain, children. All of you, I hope everyone are copying. If you didn't copy, please copy fast. 10 seconds time I'm giving. At least take a picture. Okay, 10 seconds I'm giving. I'll say sixth sum now. Okay, over. Next one, sixth sum, children. Sixth sum. What is the frequency and time period? He's asking frequency is how much and time period is also how much. What is the question? If 100 waves occurring in 20 seconds, 100 waves are occurring in 20 seconds. But what is the frequency, children? Number of waves occurring in 1 second. What is the frequency, children? Number of waves. Now, how many waves are occurring in 1 second is frequency. Okay, 100 waves are occurring in 20 seconds. How many waves are occurring in 1 second? So, children, cross multiplication. 100 into 1 is equal to 20 into x. X is equal to 100 by 20. X is equal to 5 waves. Or we will write 5 hertz. Okay, children, 5 hertz. Now, time period. Time period is 1 by frequency, simple. So, 1 by 5, 0.2 seconds. So, like this, you should do. If you know the definition properly, you can do any sum. How many waves are occurring in 1 second is the frequency. He gave 100 waves are occurring in 20 seconds. In 1 second, how many waves? That's all. Seventh question. What is the frequency and time period if 200 waves are occurring in 50 seconds? Same question. What is the frequency and time period if 200 waves occur in, same question, 200 waves occur in 50 seconds? According to the frequency definition, in 1 second, how many waves will occur? Direct proportional, children. So 200 by x is equal to 50 by 1. Cross multiplication, 200 is equal to x into 50. 50 goes down. X is equal to 200 by 50. So x is equal to 4 hertz is the frequency. Once you know the frequency, easy to find out time period. What is time period? 1 by frequency. 1 by 4, 0.25 seconds. Like this you should do. Okay, children. Eighth question. What is the velocity of wave in distance between 5 crests is 10 meters? Children, distance between 5 crests is 10 meters. Okay, and 5 crests is 10 meters. And 200 waves are occurring in 20 seconds. 200 waves are occurring in 20 seconds. So, children, nothing is given directly. You should only find out. Wavelength also not given directly, and frequency also not given directly. We should only find out. This is wavelength. 5 crests is 10 meters, means 2 crests how much? Because distance between 2 crests is wavelength. Okay, direct proportion. 5 by 2 is equal to 10 by lambda. 5 lambda is equal to 20. Lambda is equal to 4 meters. According to the definition, 200 waves are occurring in 20 seconds, means in 1 second, how many waves will occur? That is frequency. Direct proportion, children. So 200 by f is equal to 20 by 1. So f goes up, 20 is come down. F is equal to 200 by 20. F is equal to 10 hertz. Right? What is velocity? Frequency into lambda. 10 into 4. 40 meters per second is the velocity of the wave. Like this we will do. Nothing is given directly, children. Both are given indirectly. You should be in a position to do. After listening to the so many sums, you should be in a position to analyze. Okay, ninth question. Okay, children, ninth question. See here. Do this. Ninth question. If time taken to complete 100 waves is 20 seconds, 100 waves are completed in 20 seconds. Same question, children. Like this question. 100 waves are occurring, 100 waves are completed in 20 seconds, and distance between 20 troughs are precisely same, children. 20 troughs is 20 centimeters. Same, children, nothing, no panic. Okay. So, children, here you get frequency, here you get wavelength. Whether it is crest or trough, it is same one. But 100 waves are occurring in 20 seconds, means in 1 second, how many waves will occur is your frequency. So 100 by f is equal to 20 by 1. Frequency goes there, 20 comes down. Frequency is equal to 100 by 20. Frequency is equal to 5 hertz. That is frequency. Now coming to wavelength. All of you check the wavelength, children. Wavelength. 20 troughs are 20 troughs is 20 centimeters. Then 2 troughs is how much? When 2 crests is how much? 2 troughs also how much? Direct proportion, children. So 20 by 2 is equal to 20 by lambda. 2 tens are. Okay, this goes here. 10 lambda is equal to 20. Lambda is equal to 2. 20 by 10 is 2. 2 centimeters. V is equal to f lambda. Okay, children. V is equal to 5 hertz. Lambda is 2 centimeters, children. We have to convert centimeters to meters because this is hertz, no? So by 100. Centimeters to meters by 100. So 5 2s are 2 to cancel. V is equal to 1 by 10. That is V is equal to 0.1 meter per second. You should be careful with the units also. We have to take in meters, children. Okay, because hertz is, let's say, unit. I will take in meters. Okay. Next one, children. 10th question. So last question, children. All of you, please concentrate. You should be in a position to analyze what is the question. Distance between crust and trough is 5 centimeters. Children, again I am saying. Here crust is there, here trough is there. Distance between crust and trough. Okay. Distance between crust and trough is 5. If this is 5, this is also 5. So 5 plus 5 is 10 centimeters is the wavelength. I hope everyone understood. From here to here is the wave, but from here to here is the wave. Okay, children. So, and 30 waves take 12, 15 seconds. 30 waves take,
Sir,
yeah.
sir, in ninth question.
Later on, we will discuss 1 second. 30 waves take
Okay,
15
sir.
seconds. 30 waves take 50 seconds. In 1 second, how much? So this is wavelength. 30 by lambda is equal to 15 by 1. Lambda is equal to 30 by 15 is 2 seconds. This is centimeters. Centimeters we have to convert into meters somewhere. This is wavelength. This is frequency, no children. I'm sorry, I wrote wavelength. This is frequency, frequency, frequency. So V is equal to lambda into frequency 10 by 100 because centimeters to meters by 100. Don't ever forget. Centimeters to meters by 100. Frequency is 2. This is called 2 by 10, 0.2 meter per second. Okay, children, this is how you have to do. Remaining 10 sums I'll put children that you do is as homework. First 20 I open the link in the description, it will be there. First 10 sums I did, remaining 10 sums you do it as homework. Okay, na? Nandi